What's up, guys? Fantasia here, and welcome back to um, our game project, Pong. This is the second section of our writing Pong. In the previous video, we wrote this code, which is going to be the framework or the skeleton code for the game. So we've got our Allegro startup, we've got our timer set up in the graphics, we've got the game loop, the drawing, and all of the drawing code goes here, and then here's the rendering code, and then finally the variable destruction, the pointer release. Okay, so in this video, what we're going to do is we're going to go ahead and add some objects to our game. So the paddle and the ball, the two paddles and the ball. And the way we're going to do that is through object-oriented design. And if you're kind of rusty on that, then I would recommend you watch tutorial 8 and 9, where I talk about using objects and classes to represent entities or objects in the game. So for now, let's just jump right into it. So I've added some files. So this is object.h, and it is the file that contains the class declaration of the object class that we're going to be using in the game. Okay, so every object in our game is going to have these attributes and these members and functions. So every object in our game is going to have a sprite. We're going to be able to set that sprite using this function set sprite, and then we're going to be able to move our game objects left, right, down, and up. So we're going to be able to move our objects around. The update function is going to be used for objects that have a speed associated with them, and so our ball is going to use this update function. Our frame clock we're not actually going to be using at all. We're going to be drawing our objects to the screen. Set sprite or get sprite actually retrieves the sprite that we stored in sprite. Notice that sprite is inside protected. It is protected, meaning that we cannot directly access sprite from the client that uses this class, because it's in effect it's private. We can't access it. So we have accessor functions that's going to change the sprite, all the attributes of the sprite for us using set sprite and get sprite. Okay, we have a pointer to a bitmap here called layer, and the layer is going to define the the layer that the object gets drawn onto. So it's going to get drawn to our layer on the layer, and that's going to get drawn to the screen eventually. Going back here, we've got every object has an x and a y coordinate in space, is going to have a speed and all of that, speed in the x and the speed in the y. Sprite HFlip is just a flag that it's going to alert, or it's going to prompt our Allegro to flip our sprites. So in other words, it's going to flip or change the direction of it to rotate it. We won't be using that because the paddles and the ball don't need to be rotated. The invisible flag is not going to be used. Basically, it just sets the sprite to set it to invisible or not, and we won't be using states at all. So that's the sort of the main things, that the main declaration for object. Now here's our actual code for the object class, and this is basically it's the implementation of all the functions that the object can do. So we've got a draw function. If it's not invisible, draw it. We've got the update function, which updates the x and y based on the speed that we have. We have set sprite, which basically destroys or frees the sprite pointer, which is initially set to null, and it loads in the new sprite. And we are going to be using a path to the image file on our computer, and that's going to be the sprite. Okay, so for example, this is, let me bring this into view. This is the image of the ball that we're going to be using. It's a simple ball, and this is the image of um, the paddle that we're going to be using. Okay, and I just drew these up, in Paint or your favorite, uh, editor that you like to use. But those are the images that we're going to be using. So this is the paddle and this is the ball. Okay, and we're going to be setting the sprites using this move up, the move functions. And so I'm going to be putting the code for all of this up so that you can have this to use in your games. And so it's basically the object class just defines basically an entity in your game, something that can move, something that can, has its being in the digital world. So that is that. And I also have a file here called colors.h, where basically it just defines all the colors that you can use, some of the basic colors that you need to use in Allegro, and they're basically macros. So red is defined as make call 25500, basically just RGB values, and this is going to go up on the drive as well. Okay, so let's get started actually putting some objects in our game. So let's run the program as we have it. So that's basically what it does, is it just puts up an empty window and it colors it white. And that because I've got it set here to do that. So I've defined screen color here to be white, and so it's doing exactly that. So this window here, this is where our game is going to take place, and all the objects in it. So let's go ahead and put some objects in there. So what we're going to do is, I guess right about here, we're going to go ahead and define an object. Okay, and we're going to put in our paddle. Okay, so paddle, and then we're going to set it equal to, well, actually we're not going to set it, we're not going to give it a new pointer, we're not going to put it on the we're not going to allocate new memory for the paddle. We're just going to use it just like, but pass it by value and not by reference, not by pointer. So we're just going to set it equal to paddle, object paddle. And then what we're going to want to do is say, actually there needs to be two paddles, so we'll call that paddle, we'll call it player 1. Yeah, I think that is more direct, more descriptive than paddle. We're going to say player 1 dot layer, and we're going to set that equal to the layer that we have here, our layer. Okay, and then we're going to want to set player 1 dot we're going to set the sprite now. So set sprite, and we need to pass it the path of the image that we saved. Okay, so we need to pass it this, where this file is saved on your computer. So this is going to be different for my computer than your computer, possibly. So you want to set it to the path that you set your image to. Okay, and on my computer it's going to be C drive, and then it's in programming, I believe it's projects, Allegro, Pong, images, and then it's paddle. I think it's called paddle black. So, and it's a bitmap image, and so we're done with that. So that sets the sprite. Okay, and then we want to set the X and the Y, although the default is set to 0. So we should be able to see something right off the bat here. Just give me a second, because now that we've actually declared a object in the game, now we need to have it show up on the screen. So we're going to go down here to our drawing code, which is right after the logic. Okay, so we have to go down here and say player 1 dot draw. Okay, and that draws it onto the layer because that's what we've set the player's one layer attribute to is this. Okay, so player one dot draw onto the layer, and then after it does that, then it's going to show up on the screen. So let's go ahead and build this and see how it says player one object was not. Oh yes, well I need to include the file that might help. Object, and it's actually inside the same folder, so I need to put quotes around it instead of the greater than and less than sign, and it's .h. Okay. Unknown escape sequence. Oh, it's because it's a double. It needs to be. Yeah, I believe that C++ recognizes, because it's a double, it's a forward slash in front of us, a forward slash, so it needs to be, there we go. Yeah. All right, so now, okay, as you can see here, there's our image, there's our paddle. Okay, and it's right here on x equals 0 and y equals 0, so the corner is going to be up here in the top. Okay, so that's great, good so far. So now what we need to do is we need to have a way to control that paddle that we just made. So down here in the logic, we're going to have our movement code. Movement. So we'll call it paddle movement. Okay, so what we want to do is we want to set up key mappings for our two paddles. Let's suppose that, well, player one, let's say player one we will control with WASD, so WADS. Okay, so we'll say if key W, so if the W key is pressed, then we're going to say player one dot move up. Okay, so if the W key is pressed, then we call player one dot move up, which in effect is going to, if we go back here to our object, oops, not trying to quit the program. If we go up here to object.cpp and go up to object.moveUp, what it's going to do is it's going to change the Y position by an amount, which I did not specify here because there's a default parameter that I set up of 5. So if I don't put any, if I don't specify a parameter here, it's just going to default to what I put here, which is 5, which is fine for now. We might want to fine tweak that later, but we just want something to see now. So let's go ahead and continue. Key A, player one, move to the left. If key S, player one, move down, and then finally if key D. And keep in mind that all these keys, key of, key D, all of these are Allegro defines. They're basically ways, keys, they're key flags that point to the states of the keys that are being pressed at that particular time. And they're going to return a 1 if it's pressed and a 0 if it's not pressed. Move right. Okay, so that looks good for now. And so now if we save it and run, if you notice it, I'm pressing W and S. Now we can move this thing around. And if we press A and D, we can move the whole thing. However, the original Pong does not allow you to actually move left and right, so we don't want that code in there. So we're going to take that out. it was kind of a habit that I get, that if you're moving in two directions, you must be moving in the other ones. Okay, so there's that code. Okay, so now if we build that, now we can only move up and down, and there's no code for left and right there. Okay, good. Now, so that's great. Now we need the other paddle, right? So we need to go up here and say object player 2 and define that and say player 2 dot layer and set that equal to layer as well. And then player 2 dot set sprite equal to the same thing. Actually, we can just copy and paste that down here. Okay. And then we need to draw player 2, because if we don't, we won't be able to see player 2. And we need to add the code for player 2 movement. So this is player 1 movement, and this is going to be player 2 movement. Okay, so here we're going to take control player 2 with the arrow keys. So we're going to say key left, then player 2 dot move left. Okay, and then the code for right. Okay, so this code here is, all of this code is going to control the movement of both objects, both paddles. So let's go ahead and run that, or build it and run it. And something's wrong here, because your player 2 dot draw for some reason it didn't. Let's see what's wrong here. Player 2 is not moving. Move left. Oh, because we're not going to be moving left, we're moving up in no wonder. Okay. Key down, key up. Okay, so it's going to be move down and move up. Sorry about that. Okay. So now I'm controlling player 2 with the up and down, and player 1 with WADs. Okay, so right now player 2 is really in the wrong place. We want player 2 to be on the other side of the screen, so we're going to have to replace it. Put player 2 in a different spot. So the way we calculate that is we want the left edge of players. We want the right face of player 2 to be touching the right face of the screen, but we only know the X and Y coordinate from the top left hand corner. So what we have to do is we have to subtract off the part that we want to go off. So in other words, what we want to do is set the X and Y to be player 2 dot we're going to set the X equal to the screen width, which is 800, and then we're going to subtract off player 2 dot sprite get sprite width. Okay, and what that's going to do is it's going to place it so that the edges are touching. See there? So now the edge, the right face is now on the right edge of the screen now. And now it's time for a little house cleaning or housekeeping, because we need to make sure that screen width and screen height is actually in a variable and not just numbers in a parameter list, because that's just bad practice. So we're going to call screen width equal to 800, and then screen height equal to 600, and then replace all of this stuff with that. Screen width, screen height, and then basically anywhere screen width, screen height, screen width, screen height. Okay. So that just makes the code cleaner and easier to maintain, because if we want to change the screen width, we don't have to go through and change all the parameter numbers. We can just change this thing here. Okay, and then so that's that. So now we can move both paddles. So now finally we need a ball, right? So we go ahead and define a new object and call it ball, and then say ball dot set layer, or ball dot layer, because we can access layer, and then ball set sprite, and then we need to, it's pretty much the same, they're in the same folder, so we can go ahead and just, and it's actually ball black. Okay, now the ball, we want it to start to be in the middle of the screen. So what we're going to have to do is say set ball.x and say screen width divided by 2 and ball.y equals screen height divided by 2, because basically you're taking the screen here, and then you're going to divide that into 2, and where you divided it by 2, that's where it's going to be, right here in the dead center. Well, not dead center, the top left corner of the ball is going to be in the dead center. It's still going to be offset by a little bit, but it's close enough. There's a way you can actually offset it to be the center of the ball, to be in the center of the screen, but we'll get to that stuff later. Matter of fact, we'll go ahead and put a note here: set ball center at center of screen, and that'll just be a note for me later. And so we need to go ahead and draw the ball, so ball.draw. Okay, and that looks good. Let's build it, and there's our ball. Okay, so we have 2 paddles and a ball now. Let's see, there are a few things I did want to change. Like, I don't like it that the paddles they start up here. I want them to start in the middle. So we'll go ahead and change that, and we'll say paddle dot, or player 1 dot y needs to start at screen height divided by 2. Again, that's the same trick that we did for the ball here, and likewise for player 2. Player 2 dot y equals screen height divided by 2. Okay, and that's just going to give an initial position to the paddles. And like I said, remember, it's the top left corner of the thing is going to be in the middle, not the center of it. So we'll offset that. We're going to offset that, I think, in the next installment. This video was just to give just to put the objects in the game, all the objects that are going to be in the game. We might add a score counter later. But I mean, for the most part, we've got the important objects in the game. We've got the paddles and the ball. So we've made progress, and so we've got our code here for the movement, and for the drawing. Okay. Notice we don't have to delete these objects because they're not on the heap. So like we didn't say player one equals new object. So because we didn't set it up like that, we don't have to delete anything. Um, so when the program closes out and the variables go out of scope, they will call the destructor and release all the pointers like that. Okay, so I think we've reached a stopping point for just putting objects in the game. So in the next video, we're gonna add more detail, and then add some motion to the game and make the objects after the ball move, and get some movement going on. So I'll see you guys later.